All right, this is number 7. Semicircles. Find the volume of the solid whose base is bounded by the curves y equals x squared minus x minus 3. Okay, we know what the graph looks like. We've done this several times now. So it's basically y equals x and another parabola that does this. And they connect at 3 and -1. Okay, so we know this by now, that we're going to have to draw um, like a base right here, and that's going to go from -1 to 3. Okay, and it's perpendicular to the x-axis, so the thickness of this width is going to be dx. Okay, and all we need is the base. Now, if that doesn't make sense, well, I'll go back right now and kind of clarify. They want the base of the semicircle to be on this graph, touching, right there. So it's going to look something like this. Okay, maybe this is, yeah, this is good. Okay, so here's a semicircle. This bottom part is touching right here. Okay, so maybe I should draw it as with the red color, like this. Okay, and they're going to lay it out. It's kind of like cutting half a roll into slices and lining it up all from -1 to 3. Okay, so we need to find like a general volume equation for this figure right here. And as I told you before, what you want to do with this is just kind of push it over, flatten it on the ground so that this side is facing forward and the top is going something like that. Okay. All right, so a prism is basically the volume of a prism is basically base times height. The base is the top, the surface on the top. The height is right over here. And according to the graph, since that's touching the, that's crisscrossing the x-axis, it's going to be dx. Okay, so we already found our height. All we need to do now is find the letter b, which is the area of a half a circle. So let's begin like this. The area of a circle is pi r squared, okay, where the radius is right over here. And this is a full circle, but if we cut this in half, like that, we're going to have an area of the square divided by 2. So area of the square is pi r squared, and we'll divide this by 2. But the question is this: what do we use for our radius? Now notice that this length, this red length, which is this right over here, which is also right here, is technically our diameter. Okay, so I can label this as my d. Okay, my diameter will be represented with these two equations subtracted. So it'll be y2 minus y1, the upper y value minus the smaller y value. So it's going to be x minus x squared minus x minus 3. And the diameter is x minus x squared plus x plus 3. And we keep simplifying this out, negative x squared plus 2x plus 3. But we don't need a diameter. What we need is a radius. Turns out that the radius is basically cut is radius, half a diameter. Okay, so we're going to cut this in half by just dividing it by 2, which will give us our radius. So this will be negative x squared plus 2x plus 3 divided by 2. Okay, so this whole thing is my radius. Now, again, as a reminder, really be careful with these numbers because there's so much involved. It's really easy to make like a calculation mistake and your answer just comes out completely wrong. Okay, so we're going to plug this radius into our pi r squared. Okay, so pi, this is r squared. So r will be this whole thing, negative x squared plus 2x plus 3 over 2. And if you square the top and the bottom, this will become pi parenthesis negative x squared plus 2x plus 3 squared over 4. Now, this is where like most students will forget. Pi r squared divided by 2, I'm sorry, this is pi r squared, but this is now the area of this whole thing. Notice that you have to divide the whole thing by 2. So this right here Okay, this part here is this. You see it? That's this whole thing. We have to take that and divide it by what? By 2, so that we can have half the volume, not the full volume. So this would be the volume of the circular, the whole thing. We want to take that and divide it by 2. So the volume of this right here is now pi negative x squared plus 2x plus 3 squared over 4. And then what I'll do is I'll do this, 1/2. Okay, so we're going to take the half of the whole circular cylinder and cut it in half and turn it into a semicircle. All right, so now what are we going to do? We're going to attach the antiderivative, and we're going to go from -1 to 3, and this will give us our volume. Now I can simplify this a little bit. 4 and 2, that makes 8. So this will become 1/8, -1 to 3, pi times negative, oops. You know what, I can bring the pi out as well. So this is just a matter of, simplifying. You can plug it into your calculator just like this, and you should still get the same, the same answer. Okay, so I'm going to bring the pi out. So this right here will be a pi, and the rest will be just negative x squared plus 2x plus 3 squared d what? dx. Let me just double check everything. That's pi over 8. Okay, so let's plug this in. Okay, so I'm gonna go, let's see, menu, calculus, numerical derivative from -1 to 3, parenthesis, well, I'm gonna go pi over 8. So where's my pi? Pi divided by 8. And then, well, I'll put those in parentheses first just to keep it separate. Okay, and then I'm going to multiply by parentheses negative x squared plus 2x plus 3, and make sure that this is all in terms of x. Enter, and I got 4.188, which I believe is the answer. Let me check. The answer is 13.404. Okay, what did I do wrong here? Oh, you know what I did wrong? I forgot to put the squared on my calculation. So I need to copy this. Copy and then paste. And then put the square on top of that parenthesis. Yeah, so I left out the squared on my calculator, hit enter, and I got 13.404, which is the right answer. Okay, I hope that helps. Study hard and text me any particular questions and I'll try to help you out. Okay, bye.